Hi, this is Dr. Graves from CSUN Geography Department and planetgeography.org. This is a quick video tutorial that will help students learn how to take a sample from a map and compare the sample mean against the population mean in order to do a one sample difference of means t-test. It's a really good test that helps you answer the question, is the sample, in this case we're going to be sampling specific neighborhoods from Chicago, does it match or is it reasonably the same as the overall population, in this case all the neighborhoods in Cook County. So we're going to take samples from Cook County based on their characteristics. We're going to compare it to the entirety of Cook County. So what I have here is a file called Chicago_payday, and this is in ArcGIS Pro. If you're in my class, this is on the box drive and you should be able to download it. The process is relatively simple. What you should do is get yourself a blank Excel sheet and get ready to paste some data in here where we will do a quick calculation on the data. So I have two files open, ArcPro and Excel. What we have here is, if I zoom in, each of these blue squares represents a bank, and each of the red dots, which are not rendering right now, they should be getting smaller, represents a payday lender. The polygons in the background are census tracts in Cook County, Illinois, which is plays host to Chicago. And so let's go ahead and take a sample of the census tracts in Cook County. I'm going to open the attribute table so we can see what's going on here. This is a lot of data, perhaps more than we need for this. And how are we going to select our sample or draw our sample? We're going to select by location, and our input features, well, that's nice, is the Cook County census tracts, and we're going to ask it to find any Cook County census tract that intersects the Cook County banks. Pretty simple. So when I click OK, you'll notice that certain of the census tracts appear highlighted both on the map and in the attribute table. In the in-class assignment, what I'm going to ask you to do is to compare the median age of neighborhoods. So we just have to right-click on median age, and this pop-up window appears, and from it, select statistics. A window will appear here on the right, and what you'll notice is that it has the data set in one column, and that is the full population, and this is the population mean here. I believe there's a question in your learning management system about what that is, just to make sure you have it. And then the sample that we took, these are the neighborhoods with a bank in them, I believe, and that is the sample mean. So this is pretty handy dandy here. What I'm going to do is just click here. I'm going to right click just off to the right of this table that's appearing, and I'm going to select copy table. That puts it in the clipboard. I can go over to my book 1 and just paste that data in. So here's the formula, and the sample mean is X. So this is the sample here. Put that in yellow, and the population was the first. I'll put that in green. Perhaps I should not have put it there. I'm going to insert a row, and I'll put this as pop and samp bank, right? So this is the bank sample. And we could go ahead and do some of these calculations right now, but we're going to go back and draw a second sample so that we can ask some questions about how different our neighborhoods with banks in them from the population or all neighborhoods. But what we're going to do, so let's come back to map here, and we're going to select by location once again. The input features will remain the census tracts, but rather than intersecting with banks, we will intersect with the points that represent payday lenders. And I'm going to click apply. Notice that this selection column has changed, but the population column remains the same. Once again, I'm going to copy the table, and I can just paste this here. I can get rid of that and this because that's redundant, so we already have that. And then here are my payday neighborhoods, and maybe I'll put those in a kind of orangey color and call that sample payday. All right, so at this point I can actually leave ArcPro behind for the moment and focus our attention on Excel instead. So we need to convert this formula into a series of steps. And once again, we have to remember that X is the sample mean. So these are both X, and this is mu, which is this funny little character right here. And then the S stands for standard deviation of the population. And then the square root of n is the square root of the sample size. And so the sample size are here. I'll put those in red. And the standard deviation, we could put that in blue. Okay, so I think we have everything we need in order to begin calculating this. So maybe I should pull this over a little bit. I can zoom in. So the first thing is we want to subtract. We can do this x bar minus mu equals x bar minus mu, and I'm going to press F4 because we want to replicate that. So there's a difference of 1.52 and a difference of 1.20 for the payday loan neighborhoods. We don't need to think about the standard deviation at all. But so now we have in these two cells the numerator of the equation, and now we just need the denominator. So the standard deviation is there. So the next step is to take the standard deviation of the population equals B4, and we'll just freeze that reference and use it twice. Then we need to go on to the square root of the sample in the sample population, the sample count. So that's C5 and D5, but we need the square root. So SQRT, C5, and just copy that over 1, and the square root there of 184 is 13.56. So now we have the numerator and the elements of the denominator, And in order to get the t-statistic, it's pretty simple. Divide what you have there in E2 by what you have in these subsequent cells. There you go. There's the t-statistic 1 and 2. So both of those values are well beyond our magical number of 1.96. So we can say with some confidence that the sample mean, what we see here, these X bars, are different. They are statistically different than the population mean. How much confidence do you have? Well, you have to convert that number then to a confidence interval. Norm S dist is what we want to use, and it's asking for our Z, or in this case T score, comma, comma, and true. So it's hard to see. This just says 1, so we have to increase the decimal here. And there you go. Finally, a slight move off of 1.0. And so we would say, you could say that we're 99.9999 or confident, or what is the chance that you would be making a mistake if you rejected the null. The null would say that the population mean is the same as the sample mean. That would be, to find that, our chances of being incorrect if we did that is just -1 minus that. It gives us this really tiny number, and we can copy that over. Hashtags, have to widen it up. Come on, there we go. So that is for the one-tailed confidence, and then if you want to find the two-tailed confidence interval for that, just multiply it by 2, and then it's even freakishly smaller. So we have a great deal of confidence that these numbers, though they look similar, are indeed statistically different. And this is why statistics is different than just sort of eyeballing these. Now we can say with great confidence, yeah, the neighborhoods that have banks in them have a median age that is statistically significantly higher. But if you were just to look at them, you wouldn't notice that difference. So for the subsequent part of this assignment, you are to return back over to the Chicago payday map. Once again, open the attribute table, and you will repeat these steps, but this time, rather than comparing median age, the assignment asks you to run through these steps again with average family size, which is this column here. So once again, just do run the statistics on the entire population, and then take the 2 samples for payday banks, payday neighborhoods, and bank neighborhoods.